Hello, my amazing students. We are starting with 8.3. And remember, in 8.3, we're talking about compound complex fractions, where we have fractions within our fractions and simplifying them. So we're going to be talking about two methods, and the first method is called method 1, and it is the same method that you've been doing to deal with division of fractions since elementary school. So this is just an example of method 1, where we recognize a fraction over a fraction, and so division by fraction is the same thing as multiplication by its reciprocal. So we will say that this is 8 over 15 times, and then we're going to get the reciprocal of this one, which is 55 over 16, and then we will look for ways to cancel, and 8 and 16 will cancel with a 1 and a 2, and 15 and 55 both divide by 5. 15 divided by 5 is 3, 55 divided by 5 is 11, so my final answer will be 11 over 6 for that one. Now that one was not rational expressions, but that was just regular fractions, but it reminds us of the process. So here is a complex rational expression. So we're, again, since we have one single rational expression over one single rational expression, we're going to use method 1, which means that we're going to write this as 6m plus 66 over m times, and then I'm going to get the reciprocal of this one, which is going to be 9 over m plus 11. So now I'm going to factor this numerator by 6 and get m plus 11. So now I'm going to cross that one off. I don't need it anymore. So the m plus 11 upstairs will cancel the m plus 11 downstairs, and we are left with 54 over m. And 54 over m is the correct answer. All right, so now we're going to look at the first one that is evidence of needing another method. Okay, now we could get common denominators here and add these two together and get common denominators here and subtract these two, and then we could flip and multiply. But a better way is method 2. And method 2 is when we take the entire rational expression, complex rational expression, and we multiply by the least common denominator of everything. So we have a 3 and a 5, and this one over here is just a 1 and a 5. So we've got 3 and 5. 15 would be a least common denominator because this 5 does not need another 5. It is able to share with the other 5, so we got 15. So we're going to multiply by 15 in the numerator, 15 in the denominator. Now I usually put a 1 under both of those to just keep the numerator and denominator straight. So I am multiplying by 1. When I distribute this to the 15, I end up with the 5 and the 3, 15 and the 3 canceling with a 5 times 2 is 10. And then that's going to be, since that canceled out totally, it's just a 10. No denominator up there. So then the 15 and the 5 will cancel with a 3. 3 times 3 is 9. And on the denominator portion here, I just wind up with 2 times 15 is 30. And then minus the 15 and the 5 will cancel with a 3. 3 times 4 is 12. So altogether, I get 19 over, and 32 minus 12 is going to be 18. So I get 19 over 18, and that is the correct answer. So This is much easier when you have, notice the look of this. It's got two rational expressions on the top and two, in this case it's fractions, on the bottom. Okay, so anytime there's not just one fraction over one fraction, we want to use method 2. All right, so here is another problem that is going to be best with method 2, because even though we just have one fraction in the numerator, we do have 2 in the denominator. So let's simplify this one a little bit. In the numerator, we had here, let's write that a squared. Okay, so we're going to multiply by a least common denominator. Now this denominator is a squared b cubed, and a down here definitely goes into a squared b cubed, and b also goes into a squared b cubed. So a squared b cubed over a squared b cubed is my least common denominator. So I'm going to multiply by 1 in the form of the least common denominator. Now what's going to happen here is that we're going to cancel denominator and numerator of the upstairs, and we're going to wind up with a 3. Okay, then down here the a is going to cancel, leaving me with 1a and a b cubed times 2. So I'm going to get 2ab cubed minus, and down here the b is going to cancel, and I've got an a squared times an a squared is going to be an a to the 4th b squared. So we'll write that out a little bit nicer here. So we get 3 over 2ab cubed minus a to the 4b squared. Okay, now we could factor that denominator and that would be fine, but it's not going to change the fact that we cannot cancel anything. But let's just make it a little bit nicer by factoring it. So I'm going to factor it over here. 3 on the top, and then I can pull out an a and a b squared. So if I pull out an a b squared, I'm left with a 2b minus, okay, so we got an a cubed left over. So this is the way that the book left the answer. Okay, we usually leave the denominator in factored form when we can. So that is the way that they left that answer there. So I'm assuming that your Connect Math is usually going to refactor the denominator even if it does not cancel. All right, so let's do another one of these, which is this one right here. And on this problem, we're going to look for a least common denominator. This is definitely a method 2 type of problem because I've got 2 rational expressions on the top and 2 rational expressions on the bottom. Remember, I only want to use method 1 when I have 1 rational expression on the top and 1 on the bottom. So I'm going to look for my LCD and multiply through by the least common denominator, which is going to be h times h plus 5 over h times h plus 5. And I usually just put a 1 under there to help me remember. And now when I distribute the 3h over here, the h's will cancel, and I'll be left with 3 times h plus 5. And then plus, this one distributes, the h plus 5 will cancel, and I'll be left with a 2h. And in the denominator, the h plus 5 will cancel, and I'll be left with a 6h. And then in the second one, the h's will cancel, and I'll be left with a h plus 5. Now I'm going to leave this in a parenthesis because that minus has not yet been distributed across there. So when I simplify, I've got 3h plus 15 plus 2h. Now I'm just going to go ahead and add the 2h because we're out of space. So the 2h and the 3h give me a 5h. On the bottom, I've got a 6h minus an h, which is going to give me a 5h minus a 5. Now, can you see that both of those are going to have a 5 as a factor? So when and I'm going to do this right up here because I've run out of room. So when I pull out a 5, I'm going to get a 5 times h plus 3 over a 5 times h minus 1, and my 5's cancel, so my answer will be h plus 3 over h plus 1. And now we only have 2 more problems left to be done with this section. 2 more problems. This one is definitely set up for method 1 because you see I have one big rational expression on the top, one big rational expression on the bottom. I'm just going to flip and multiply. Flip the second fraction. Now what I'm going to do is I'm going to take this and put it up here, w squared minus 16 and 9w minus 63, and then I'm going to erase all of that. And now we are very, very close to, okay, so what we're going to do is factor, 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 factor. When we factor this one, we're going to have a w plus 7, w minus 7. When we factor this one, we're going to have a 6 times w plus 4. When we factor the numerator up here, it's going to be w plus 4, w minus 4. When we factor the denominator, we're going to pull out a 9 and get a w minus 7. So now that I factored everything, it looks much friendlier because I can cross out a w plus 4 on the top and the bottom. I have a w minus 7 and a w minus 7, so that my final answer is going to have a 54 on the bottom and a w plus 7 times a w minus 4. And those, that one is finished, and we have only one left to be done with 8.3. This one is talking about those negative exponents. I showed you one like this in class. We are not able to move the m downstairs because m is not a factor. So what we have to do instead is go ahead and turn it into 1 over m right in its spot. So this is going to be 1 over m minus 8 over n squared, all divided by 1 plus 1 over m squared. So basically I took the m to the negative 1 and I turned it into a 1 over m. I took the negative 8 and it went upstairs because the n squared is going to go down here. Remember, the exponent only applies to the number of the variable directly preceding it. The 1 comes down and the m squared in the bottom is going to go here. So each one is just doing the 1 over reciprocal thingy right in its spot. So now what's going to happen is I'm going to multiply the whole thing by 1 in the form of m squared n squared, and on the bottom m squared n squared. And when I distribute this to this, I get 1m knocks out, cancels out, so I get mn squared. And then here, the n squared cancels, so I get minus 8m squared, minus 8m squared, and then this one times this just gives me m squared n squared plus, and on the other side the m squareds cancel and I get an n squared. Okay, so if I factor an m out of the numerator, I'll just do it right here. If I factor an m out of the numerator, I get an m and an n squared minus 8m. Okay, and that is correct. And on the bottom, I factor out an n squared, and I get an m squared plus 1. And there's absolutely nothing else I can do with that. That's as simple as I can get it. So that would be your final answer for that one. That is the end of 8.3, which was dealing with complex rational expressions. And this is Mrs. A, and may God bless your day.